Okay, and welcome to our second video on simultaneous equations. In the first video we looked at linear equations, ones that are straight line. We looked at two methods for doing it, elimination and substitution. What we're going to do now is apply basically those same techniques, but we're going to have a look at situations when the equations are not straight lines. So here we go. I'm going to use three examples to work through just to give you an idea of what's going on. So the first one, example A, we've got two equations. Our bottom one there, that's our straight line. Hopefully you might recognise that our top equation there certainly isn't a straight line. In actual fact, that's a reciprocal curve. So let's solve these two equations and then have a look at what that looks like if we were to plot them on a graph. First thing I'm going to do is take that top equation and rearrange it to make y the subject. And then I'm just going to take that y equals 6 over x, take that 6 over x and substitute it into the equation. So it's basically exactly the same technique as we saw in the previous video. It just gives us a slightly more awkward looking equation. We've got x on the bottom of a fraction here, so let's just multiply the whole equation by x and deal with that. And you can see very quickly it turns into a quadratic. We've got to solve a quadratic now. To do that, the equation's got to be equal to 0. Bit of rearranging. There we go. And now we're going to look to solve that quadratic either by factorising or completed square or quadratic formula, whichever one is your personal preference. I know with this one it will factorise quite nicely, so there we go, and that gives us values of x. You'll notice now we've got two values of x as we expected from a quadratic, so I've got 9 over 2 and minus 2, so we've got to put both of these values back in to find their associated y values, and when we do that we get two values for y. So our solution, we've got x is 9 over 2, y is 4/3, and when x is minus 2, y equals minus 3. And if we plotted that graphically, that's what it's going to look like. The red curve, that's my reciprocal curve, that's x, y equals 6, or y equals 6 over x. And the blue line is clearly the straight line, 2x minus 3y equals 5. And again, we can see our solutions here. There's 4.5, or 9 over 2 for x, and the y is 4/3. And our other point, x is minus 2, and y is minus 3. Now we did that by rearranging the top equation. We could do it by rearranging the bottom equation and just basically doing the substitution the other way around. We don't need to. You don't need to do it both ways. We've already got a solution over here, but I'm just going to do it the other way around just to show you that it will work either way. So here we go. Rearrange it, make it say x equals, and now we've got to substitute this expression back in to there, and now we're ending up with an equation just in terms of y. Multiply out, and I've moved the 2 over to the other side as well. That's where the 12's coming from. And you can see now we've got a quadratic in terms of y. Get it equal to 0. Factorise. There's our two y values, same as we had before. And there's the equivalent x values to go with them. So it doesn't matter which way around you do it. It will work either way. It just depends on which way you prefer to do it. Okay, on we go. Part B. This time we've got two quadratic curves. We've got a positive quadratic there, and you'll notice we've got a negative quadratic here. And in this case, both of those curves are equal to in the form y equals. So we can just say, well, this thing here is equal to this thing here, and put the two next to each other. There we go. There's our quadratic. Again, do the rearranging so it's equal to 0. There's our quadratic in terms of x equal to 0, and again, solve by whatever the method you think is most appropriate. I've decided to factorise, and so from there we get x is minus 8 over 3, and we get x is 7 over 2, and then just go back to whichever one you think is easiest to use and come up with the y values, and there they are. Not the nicest numbers in the world, but you know what, I'm sure you'll be able to cope with it. If we have a look at these on the graph, there we go, there's our red curve, there it is, that's our positive quadratics, that's the 4x squared plus 4x minus 51, and the blue one, there it is, that's our negative, and again you can see we've got 2 points of intersection, which is why we've got two sets of solution, one set there, and there's our other set. Okay, and on to our third example now. So this time what we've got is this equation here, which is an equation of a circle, and we've got a straight line, so we're going to see where this straight line goes through the circle. Again, this is already in the form y equals, so we just need to take the 12 minus 2x and substitute it into our top equation. We've got some multiplying out brackets to do here, and I'd always advise just kind of coming out to the right hand side, do a little bit of careful thinking, making sure you've multiplied out it correctly and tidied up all the bits that you need. There it is, before we then go back and include that in our equation and tidy it up and put it equal to 0, and there we go, and off we go again. We've got to solve it. Now this one won't factorise, so you might say, okay, well, let's put it into the calculator or quadratic formula. But with this one, as it turns out, there actually is no solution. Now, what does that mean? Well, first of all, no solution. We should know that that means b squared minus 4ac is less than 0. So let's just have a look at that and see what's going on. There it is, b squared minus 48 squared minus 4 times a, which is 5, c, which is 124. And there you go, that's why we've got no solution to this equation. But what does that mean in terms of what it looks like on the graph, in terms of this circle and this straight line? Well, it means that they just don't intersect. Here's our circle, there's our straight line, and the two things just don't meet, which is why we ended up with a quadratic equation here that didn't have any x values that would solve it, because, like I said, the line and the curve just don't intersect.